Hi everyone, welcome to Grade Up. My name is Hemant Parihar. Earlier we have seen predicates and quantifier. Today we are going to start the most important topic in preposition logic, that is how to translate English statement into mathematical statement. It is very important because once you learn how to translate English statement to mathematical statement, that means you understand the English statement very well. Your understanding will improve. So let's get started. So see this sentence. First sentence, you can access the internet from campus only if you are a computer science major or you are not a fresherman. So in this statement this one is very important, only if, because I earlier told you that there are various forms to represent the implication, and only if is also one of the form to represent the implication. I tell you many form of implications, so just remember all those forms, don't forget them, they are very important and they will come again and again, like this, that it come only if. So what is only if? It is P implies Q or Q implies P. We have to identify what is only if. So if I say Q only if P, Q only if P, it does not suit, because when P is not true, even then Q can be true. So this is not the case. So what is P only if Q? P only if Q is P implies Q. So we understand that this will be our P. This, you can access the internet from campus, this is gonna be P, and all this remaining will be Q. Okay, all this remaining will be Q. So here we are, you are a computer science major or you are not a fresherman. So here we are or is used for disconjunction. We have already seen it. So first we have, this is what is, we represented this statement, you can access the internet from campus by A, okay, you are a computer science major by C, and you are a fresherman by F, and we are given here is you are not a fresherman, okay. So how to convert that statement into mathematical statement? It will be like that, A implies C or not F. Not F means you are not a fresherman. So only the important part in this was only if. So once you remember all the forms of P implies Q, you will not have any problem in this question. So now let's see another example. Importance of domain. Domain is very important. Like see this statement, every student in this class has studied calculus. So first word is every. So every, you will be thinking that we should use for all x. Yes, we have to use for all x, we will be using that. Every student in this class, so it is saying in this class has studied calculus. So every student in this class has studied calculus, okay. Cx represent x has studied calculus. Now what is x? That is the question. What is x? If x is the student in this class, then we can represent this statement very easily. How? We can represent this as for all x, Cx. This means that for all student in this class has studied calculus. That simple it is. But if x is not the student in this class, if x is per people in the world, x can be any people in the world, then we have to do something. We have to introduce another variable to show that that person is in the class. So person x in the class is represented by C, S of x. So how to represent that statement? Every student in the class has studied calculus. So for all x, if x is a student in this class, that implies x has studied calculus. So in this way we represent this statement into mathematical statement. So you understand the importance of domains. When you don't define the domain, then you will be having problems. So in question it will be properly defined and you have to do the question accordingly. So focus on it, okay. So let's see this question, GATE CSE 2009. Which of the following is the most appropriate logic formula to represent the statement? Okay, gold and silver ornament are precious. So our statement is gold and silver ornament are precious. So here you will be thinking that there is not all, but this sentence implies that it will be for all gold and all silver. Okay, so these following notations are used. G of x, x is a gold ornament, S of x, x is a silver ornament, and P of x, x is precious. So try yourself. First pause the video and try it yourself, then we will see it. Okay, try it. So here we are given gold and silver ornament are precious. So this sentence is saying for all gold and silver. It is for all gold and silver, not only a single piece of gold. All gold and silver are ornaments are precious. So we will see this example. So what is saying this? For all x, where x is, what is x? Okay, x is any metal that will be x. Okay, for all x, px implies, if it is precious, then it is implies either it will be gold and silver. That is not the correct one. See this statement, fourth one. For all x, if x is gold or x is silver, this implies p of x. That means it is precious. So it seems to be true. But you will be saying that here we have used and. So that means this conjunction we should use the and symbol. But here we are using the or. Actually understand the statement, what it is saying. Gold and silver ornament are precious. So both gold and silver ornament are precious. It is not that only silver and only gold is precious. Both are precious. So here we should use or. You have to understand the meaning of a statement properly. Only then you can convert it. Now we will be seeing example from true variable predicate. What is true variable predicate? In true variable predicate we will be having two variables, like here we have x and here we have y. So what this means? Likes x comma y. So that means x likes y. X, who likes? X who likes y. If I write x here, then that should become first here. Okay, now we will see more example. Rahul likes Priya. Who likes? Rahul. So how should I represent this statement? Likes Rahul Priya. So Rahul should be at here and Priya should be at here. You cannot interchange them. That is important. So I have defined it very well here. Okay. Now see the second statement. Rahul likes everyone. So Rahul likes everyone. So everyone's come here. So how to convert that? First we have Rahul likes Priya. Okay. Rahul likes so else, you can say Sita or Ram and many all. So all these people Rahul like. So where should this variable x should come? X should come at this position. That is important. So Rahul x. So for all x likes Rahul comma x. So that's mean for all x, x is the people and Rahul likes everyone. Okay. So this is the translation of that statement into mathematical statement. See third example. Everyone likes everyone. Everyone likes everyone. So Rahul likes everyone and then you likes everyone and then other people will likes everyone. So everyone likes everyone. That is the meaning of the statement. So for all x means we are considering all people, such that for all y likes x comma y. So x likes y and what is y? Y is all people, for all people. So y is all people. Okay, and what is x? X is also all people. So everyone likes everyone is the meaning of that statement. Someone likes someone. So here someone likes someone. Okay. There exists an x. For someone we will use essential quantifier. Why? Someone. So you are not fixed what is that person, also someone, but yet it is there that someone will be there. So that's why we will be using essential quantifier, that is there exists an x such that there exists an y likes x likes y. That means there will be an x such that there will be an y and x likes y. So this is the translation of that statement. Fifth example. Someone likes everyone. So there is someone who likes everyone. Like we have seen the Rahul likes everyone. In previous example we have seen Rahul likes everyone. So it is like that. So someone likes everyone. So there exists an X such that for all Y likes X comma Y. So X likes everyone. That is the translation. Okay. Everyone likes someone. Understand the statement. Every statement is different from each other. You are seeing that everyone and someone is in all the statement, but no, every statement is different in each one. So understand this statement. Everyone likes someone. So it is true. We all like someone. So everyone likes someone. For all X, there exists a Y such that X likes Y. This is the translation of that statement. So everyone likes someone. Everyone is liked by someone. Everyone is liked by someone. So this statement is saying that everyone is liked by someone. You are also liked by someone. Me also liked by someone. Everyone is liked by someone. And this statement is different. Everyone likes someone, that is different, and everyone is liked by someone, both are different. So understand the statement properly. So how we will convert it into mathematical statement? Everyone is liked by someone. Okay. So for all X, there exists a Y such that Y likes X. So who is liking? Y. There exists a Y. Everyone is liked by someone. Yes, we should use the Y at here. Understand it. Because who is liking? Y is liking X. So there is exists someone Y who like X. And we have for all people, that is true. So this is the translation of that statement. Someone is liked by everyone. So this statement is different. Someone is liked by everyone. For example, Sachin Tendulkar is liked by everyone. So that is that kind of meaning this statement has. We all love Sachin Tendulkar. So someone is liked by everyone. How to translate it? There exists a Y, okay, that is liked by everyone. So there exists someone who is liked by everyone. So there exists a Y such that for all X likes X comma Y. So X is liked by, there exists a Y such that for all X, X likes Y. So that is the translation of that statement. Nobody likes everyone. That is true. We have some hater also. So nobody likes everyone. So how to convert it? Here it is nobody. We can also translate that statement like that. For everyone, there is someone that does not like him. For everyone, we have someone that we don't like it. So for all X, there exists a Y such that Y not of like Y comma X. So that means Y does not like. For all X, there is someone that does not like them. So everybody likes everyone will be converted like this. Okay. And now we will try to understand that diagram from this. How I will tell you. So what is this? You will not be understanding. That means it for all X, for all Y, P of X comma Y. So we are adding P of X in everyone. Every statement we are adding that. Okay. So that diagram means that. Okay. For all X, for all Y, P of X comma Y. So that statement, what does it mean in our examples? It will be like that. For all X, for all Y, likes of everyone likes everyone. So that is the meaning of statement. Suppose it is true. Everyone likes everyone. This statement is true. So what does it implies? What does it imply? It implies that there exists an X such that it will be liked by everyone. Because everyone like everyone. So Rahul like everyone. Okay. You like everyone. Me like everyone. This is true. I am saying this is true. So that means there exists an X which is liked by everyone. Which like everyone. So Rahul likes everyone. So it is true. If this is true, then this is also true. That what it means. So Rahul likes everyone is true, and you like everyone and me like everyone. If this is true, then obviously there exists an X. For all X, P of X comma Y is also true. Also for all Y, there exists an X such that p of x. So that statement will be like, I will tell you, everyone is liked by someone. That is like that. For all x there exists y. For all x there exists x. For all y there exists an x such that p of xy. So that means that everyone is liked by someone. Everyone is liked by someone. If this statement is true, if this statement is true, then obviously this implies this. So that is the meaning, that if this is true, then this is also implies that this is true. If it is false, even then it can be true. But if this is true, then it has to be true. That is the meaning of P implies Q. You have to understand only this statement very carefully. You understand this statement, you understand whole proposition logic. So for all x, for all y, if this is true, then obviously there exists an x and there exists an y such that p of xy is true. So that is what this is meaning. You will be asked question like that, identify which of them as tautologically. So they will give you like that, for all x, for all y, a p of x comma may y implies there exists y, there exists x, there exists x, p of x comma y. It is true, and I am explaining you it with the example. You can also do it with some trick like restricted your domain to some only 2 variable and then try to solve it. You can also do it. We will be seeing that how to do it, but understanding it by the statement is very important. Okay, so that is what the meaning of it, and similarly that is there. So that's all from here. It is very important to understand this example, so see it again and again. It is only you need to understand this example very properly. So practice a lot of them. There are a lot of examples in Rosen. Try to practice them, and until you feel confident, try to practice them. Thank you.